14.2 part 2, we're doing transformations again. Now we're looking at the vertical, horizontal shifts and the reflections. So we'll start with a couple of vertical shifts. First example is going to be y equals cosine x plus 1. So that's where we have, if you compare to the original equation, we have y equals a sine b x minus c plus d. The d is 1, so this means we move it up 1. So it's a shift up 1. That's it. So we are going to graph this. We'll do the same process. We'll scale our axes. The period is still 2 pi, so we go out to, we'll do the y-axis first. So the highest is 1, the lowest, oh, okay. Now, on the vertical axis, since everything is shifted up 1, here's the key difference. That you have to first mark on the y-axis where the middle is. So the middle is at 1, and you need to put to remind you that the middle is right there, put a dotted, it's not a part of your graph, but it's a dotted line at the middle of the wave, 1. So what is the amplitude here? Has anything changed about A? The amplitude is still 1, so what's the highest point and the lowest point? If the middle is 1, what's the highest? 2. Yes, good. So we're going to put a mark at 2. And what's the lowest? Lowest? 0. Okay, so the height of the wave is 1. That means from the middle, the highest you go up is 1, and the lowest you go down is 1. That's like always. But the middle has been moved up to 1. So the middle of your wave is now at 1. So it's like the new 0. 1 is the new 0. You know how with sine we always started at 0? The middle is now moved. Okay, so on the x-axis, nothing's different. So you still go to 2 pi, the middle is pi, and then cut those. So now we have the outline. So it's cosine though, so we start at the highest or middle? Highest. So here we go. Since we have the outline, we can't go wrong. So we go high, highest, middle. That's why I keep saying middle. I don't say 0, I say middle. High, middle, lowest. This is the lowest point. Middle, highest. So that works the same way. High, middle, low, middle, high. And you don't really need to think about it past that if you get the outline right. So let's try another one. This is still going to be a vertical shift. So we'll do y equals sine x, y equals sine x minus 2. So we're going to we'll scale our y first to be consistent. I'm going to make it a little bit like that because I know it's going to be moved down 2. The center of the wave is moved down 2. That's what the minus 2 does. So right away, put the middle of the wave, okay, is at negative 2. And put a dotted line there so you know that's the middle of your wave. So what would the highest and lowest points be if the amplitude, since we know the amplitude is 1 still, because there's A is 1, what's the highest? The highest is negative 1, yes. And what's the lowest? Negative 3. So the amplitude is still 1. So, and then on the x-axis, that's all the same. So 2 pi, we're going to do 1 period, which is 2 pi, pi, cut that in half and half. So our outline is all there. So sine, where do we start? At the highest or at the middle? The middle. Exactly. The middle is negative 2. It's not 0. It doesn't even touch 0. So you go middle, right? Start at the middle. Middle, high. Notice the high is negative 1. Middle, low, which is negative 3. Middle. And so it looks like the nice, happy little sine wave we know and are familiar with. It's just the whole thing is shifted down 2. So those are our vertical shifts. So now we're going to do horizontal shifts. So horizontal shift. So this will change sort of how we scale the x-axis. So we're going to do y equals sine of x plus pi. And again, we're limiting it to just one transformation at a time. So this is going to move. I already know this is going to move it to the left pi, because remember it's the opposite. So c is in this case is negative pi. So this moves to the left pi. That's the difference. Otherwise, everything else is the same. So I'm going to start over here. And so first I'm going to do my y-axis just to be consistent. The amplitude is 1, and so the highest and lowest are 1 and -1. That has not changed. Now, but the x-axis, I need to just move everything to the left pi. So I'm going to start at my graph at negative pi. And since I'm doing one period, how far to the right what will I add to this to get to the furthest to the right? You're going to add 2 pi, so -1 plus 2 is, yeah, so you go from negative pi to pi as a complete period. And we're going to cut it in half and in half again, so the middle is at 0. And then we cut this in half, which would be pi over 2, and cut that in half. But we don't need to label it. So we'll label 0. So that's all ready. So now everything's ready to go. So sine, do we start at the middle or the highest? Middle. So you go middle, middle, high, middle, low, middle. Middle, high, middle, low, middle. So it's just everything shifted to the left by pi. That's the only thing that's different. Let's do another one of those, of the horizontal shifts. So example 4 is going to be here. Example 4 is y equals cosine of x minus pi over 2. So I already know just by looking at this that I'm going to move to the right pi over 2. Okay, to the right pi over 2. Everything else stays the same. So I'm going to start with the y-axis. The highest is 1, the lowest is -1. That doesn't change because my amplitude is the same. But I'm going to start to the right pi over 2. That's my starting place. My ending place, since I'm doing one period of it, is you'd have to add 2 pi to this. 2 is, so that's 5 pi over 2, or yeah, 5 pi over 2. So you go from there to 5 pi over 2. I just added 2 pi to the leftmost point. And then the middle is halfway in between this. If I add these up, I get 6 pi over 2, which is 3 pi. That doesn't sound right. 6 pi over 2 divided by 2 is 6 pi over 4, which is 3 pi over 2. There we go. And then in half and in half again. You always need 5 places. We're all ready to go. So what's the, they start at the middle or high? High. So high, middle, low, middle, high. So it's the same cosine we're used to. And now you could fill it, normally we fill it into the y-axis. For now you can just sketch it so that so there's not a gap between that and the y-axis. You can just continue it a little bit. Okay, but we'll leave it at that for now. The last one is this one is going to be the last kind of transformation is a reflection. But you're used to this because remember, like when you graph y equals negative x squared, just really quick, it flips it right down over the x-axis. That's what y equals negative x squared looks like, right? So if you throw a negative in front like this, y equals, let's say, negative cosine of x, and I want to graph that reflection. So now, instead of starting, so you're going to start at the lowest point. Instead of, normally cosine starts at the highest, that's the key. If you see a negative in front, you're going to start at the lowest with cosine instead of the highest. If it were, and we'll do one with sine as well. Is that your question, John?
Yeah.
Yeah. So, great question. 2 pi, pi. Okay, so all we do, negative y equals negative cosine x, start at the lowest point, low, middle, high, middle, low. So there we go. Low, middle, high, middle, low. That's what negative cosine x. It's just flipped over the x-axis. So with sine, now I'm kind of doing your homework for you, but I don't really. I'm just going to do it anyway. So y equals negative sine x. We'll do other examples Friday that are not like this. So again, go out to 2 pi, half is pi, half, half, highest 1, lowest negative 1. Just set up that outline. And so for sine, you still start at the middle, okay? So you start at the middle, but normally sine increases, but because of the negative, it's going to decrease. So you go middle, low, middle, high, middle, middle, low, middle, high, middle. And so there's y equals negative sine x, reflected over the x-axis.